Welcome to the High Pressure Podcast with me, George Rotterman.
And me, Marie Williams. Brought to you by Reliably Ratterman.
Bringing you industry news and trends.
Plus, insightful conversations with industry leaders.
Let's get to today's show.
Welcome to the High Pressure Podcast. We are here with myself, Marie Ratterman, and our co-host, or potentially our main host, and I'm the co-host, we don't know. That's George Ratterman. Hello, George.
Hey, Marie, how you doing? And I might just co-host today. It just depends on exactly what we're going to talk about.
Yeah, I need you to not co-host because we're talking about something I don't know much about, which is CO2 today. And that is a perfect segue into introducing our guests here. We have Jeff and Luke with TomCo. And gentlemen, welcome to the podcast.
Thank you. And hey, I have to start right now. You don't need to worry about co-hosting because whenever Jeff has a camera in front of him, he will talk for, what do we have, an hour here? I mean, I think he'll probably run it for 2. So I think y'all are safe today.
Fairly certain I haven't even spoken yet, so not an
Well,
idea.
Jeff, you can't.
Hey, co-guest.
I had to get the words up quick because I know that's going to be the end. The last you hear from me on this episode. So
I mean,
perfect. Now it's worth watching. Everybody stay tuned.
Yeah, Jeff, you can't run 2 hours because that's going to run into, happy hour time. So we got to stick to one.
Watch those views just fall off a cliff.
Yeah.
I like how you guys do happy hour out there since you're 3 hours behind us. Good job.
No one can know that.
They do now.
Okay, I'm going to continue with the podcast. So, Luke and Jeff, it's so great we have you on because exactly why we have you on is so you can talk about all kinds of good things we want to learn about today. And today is going to be about CO2. And a lot of it has to do with how we're using CO2, but also what things are happening in the CO2 and emerging in the market of CO2. One of the big things people talk about is recovery. I thought maybe a nice spot to talk about would be a little bit starting with recovery.
Yeah, no, I mean, well, first off, really, really glad to be here. Thank you both for having us. Love the Ratterman Group and everything you guys do, and great partners of us at Taylor Wharton TomCo Air Water. So first, just want to start with that. Jump into CO2. Yeah, recovery. There's 2 ways to look at recovery or think about recovery. There's the recovery for our industry is mostly going to be considered off of dry ice. So when you're producing dry ice, you use roughly 2 to 2.5 pounds of CO2, liquid CO2, to make 1 pound of dry ice. So you're losing 1 to 1.5 pounds of CO2 every time you make ice. And so that's really where the recovery market has really started blossoming in the last few years. For large production houses, they've always recovered where it's made financial sense. But when CO2 is so cheap, pulling off of a dome anyway, you didn't do a lot of recovery because the capital expense didn't justify it. But obviously, anybody in the CO2 business these days knows CO2 has been escalating in price, by multiples 3 to 5 times over the last 5 years. And it's only going to continue to increase by all estimations. So recovery makes so much more sense now.
And Jeff, the other part about recovery is there's actually shortages of CO2 in certain parts of the country, right? So if you can recover that takes care of some of the gap you might have even be able to find CO2.
No, that's one of the best ways to look at it. I mean, you hit it on the head. I mean, when you're just doing it based on my lost CO2, the math doesn't always work out. But if you're on allocations or you can't get more CO2, then you really have to do that ROI calculation based on the lost opportunity. Your opportunity cost, lost opportunity cost of not selling that more of that ice, the margins that you didn't make. So
right.
100%, it makes total sense. If you have dry ice and you have more than one pelletizer, even if you have one larger pelletizer, the math generally pencils out very well to get into recovery space.
Yeah. So let's just talk about that real quickly. The basics on dry ice. We're all hearing about dry ice. I mean, there's applications for blasting instead of using sand, and there's a lot of the. Why don't we hit real quickly the 4 bullet points, the most common dry ice applications?
Yeah, give me the 4 bullets, Jeff. No, I think George, you nailed it. The use of dry ice, basically taking those really refined rice pellets and blasting them to clean equipment. You don't have the cleanup that you would with sand because that dry ice turns right back into a vapor. It doesn't turn into water. No mess. We also see it a lot in food freezing and in vaccines. That would be 2 and 3 for me. Food freezing, as you produce the food, you need to find a way to transport it to make sure that it doesn't go bad on you. And so we see the food producers using dry ice to mix in with their product to help retain the water weight of that product. The dry ice does a lot for those business segments. And these food companies, they are such large users of dry ice that a lot of them actually produce it on their own. Many buy from the large suppliers of dry ice, but some even produce their own in-house. On vaccines, and we saw it with COVID, it's critical to keep these samples frozen or they go bad, and you're losing millions of dollars of product if that were to happen. It's so critical, the infrastructure and the requirement to have something like dry ice to freeze these products. Those are really the markets that we see dry ice use. And then the fourth would be, I think, the most the one we see emerging is that shipping direct to consumer. So different food products, not necessarily meats, but anything, you could be frozen vegetables and fruits that is showing up on your doorstep as people are trying to be more healthy, as you see organic coming into play, or farmed sustainability. And a lot of the conversation today will be about sustainability, but people are sourcing their food differently. And so these companies are using dry ice to kind of maintain the integrity of the product that's shipped to your doorstep. So those are really the four pillars right now, and those markets are growing. They're growing very quickly.
Yeah, and I think COVID probably helped speed it up a lot. Like people that maybe weren't exposed to Zoom during COVID, all of a sudden food is shipping all over the place. Right now,
I hope you were holding that stock. Where do I buy the dry ice stock? But exactly,
right?
Great way to think about it.
There's so many interesting applications of CO2, many of them. But the big piece we're talking about is recovery. And then when we look at recovery, there's also one of the aspects you have to look at recovery is a lot of power. Is it a lot of power to take care of doing recovery work on CO2 equipment?
Yeah, power consumption is definitely something that we're looking to overcome. And I think I'm going to bring this around to power, but talk about, the way our industry, the industrial gas industry, understands recovery is off of traditional sources, dry ice or maybe ethanol, where the CO2 content is very pure and it requires less energy to separate the impurities from that pure CO2. And then at that point, we're going to compress it and we're going to turn it back into a liquid to be reused. But in some of these emerging markets of recovery, if we were to kind of expand outside of our industrial gas bubble, if you were to turn on the news and you hear about recovery, they're talking about the initiatives to reduce greenhouse gas emissions and the focus on climate. But those sources that they're trying to pull CO2 from, and we do a lot of work with these partners, are low purity CO2 sources. And so it takes a lot of energy to get to the same purity standards that we are used to in the industrial gas industry. And so energy is a huge concern. But on capture off of dry ice, your OpEx is overcome by what you're able to sell that dry ice for to your customers, having that excess ice. When you're dealing with impure sources, the air, it's 0.04% CO2, to get that up to 99.99% CO2 or beverage grade CO2, it takes a ton of energy. So as you get less pure on the CO2 scale, you use a lot more energy. And there is kind of a break-even point right now where it doesn't make sense to capture CO2 just based on the cost, kind of the floor of CO2 pricing available in the market. So emerging technologies are absolutely focused on improving their efficiencies to bring down the cost of electricity or the consumption of electricity in their capture process.
So for a typical gas distributor that's either in or thinking about getting into doing their own CO2 rice or blocks, what would you say if you were going to look at 2.5 pounds of CO2 to produce and manufacture 1 pound of blocks, let's say, by putting in carbon capture, what would that change to? Instead of losing 1.5 pounds for every 1 pound you made, what would it change to with the carbon capture?
Yeah, we're going to capture around 1.2% or 1.2. Well, conversion rate would be 1.2 to 1. So there's a couple little losses within that system, but you're going from 2.5 pounds of liquid to about 1.2 pounds of liquid to produce that same amount of ice. And everything else is getting captured and recirculated back into your tank. And so, George, the nice thing about that is, as you talk about the cost of power, we can look at the energy consumption, we can look at the price per kilowatt hour, and then we can look at what you're selling your dry ice for. And as Jeff was mentioning earlier, now you're paying for that 2.5 pounds of liquid CO2 from your supplier, no matter what. Right. How much of it can you sell? If we can offset the cost of energy by recovering that extra 1.3 pounds of CO2 and then creating dry ice with it and selling that, what is that additional revenue and profit, and does it offset your energy? And we can very quickly calculate that. But yeah, the conversion's excellent, down to 1.2 pounds to 1 pound of ice created.
Yeah, which is outstanding.
I'll differentiate the market a little bit. We kind of look at it as what we call kind of small scale recovery, mid scale recovery, and large scale recovery. So that 1.2, 1.3 that Luke's referencing, that's more on that large scale recovery. If you have multiple pelletizers, it's block presses, you're talking 50 tons to 100 tons, 150 tons per day of gas that you're recapturing. That's a full scale system, and that absolutely can get down to that 1.2, 1.3. When you're talking small scale, you're running one pelletizer and making 1,000 pounds per hour, 5-6 hours a day. That's a little more difficult today to capture down to that 1.2. You're really seeing kind of 1.5 to 1, 1.8 to 1, just depending on the provider of that equipment. And the reason for that is partially is because all we really did was scale down a 150 ton per day plant down to a 1 ton per day plant, or smaller scale system, because there was never a reason to innovate on the technology for small scale recovery, because why would, right? Like if you're doing a ton per hour or a ton per day of CO2, why would you want to liquefy it and capture it? It didn't cost that much, now it makes sense. So we're spending a lot of time and focus and energy on improving that small scale recovery, and then focusing on that middle scale recovery, which in our independent gas distributor marketplace that we all live and breathe around, that's kind of where most of them are, right? They're in that, they have a pelletizer, maybe two pelletizers and a block press. They're running one shift a day, 5 days a week. So the market really is still just now kind of coming to fruition for products to kind of enhance their needs. So right now, I'd look at some of the smaller guys are going to see 1.5 to 1.8, but that's still down from 2.5. That's a big gain.
Well, yeah. Just the fact that you have a shortage and you're only getting an allocation of 80% of what you normally need, that gives you a tremendous amount more product to go out and be able to service your customers and grow your market.
Can we discuss the process of recovery, like how people are doing that and what they're using?
Yeah. I'll go ahead and just kind of bring it down to its fundamentals, the simplest way, because that's the only way I understand it and can describe it anyways, right? So what's happening right now, and we'll focus on ice and then other sources. When you produce that dry ice, you're compressing that liquid to turn it into a block. It flashes essentially, and it becomes a solid. And in that flash, because CO2 can live in 3 states, it flashes off the gas. So the liquid is creating a solid and a quick flash of gas. And that gas comes out at atmospheric pressure, kind of just what we're standing around right now. And what the recovery systems would do is they're going to grab that and they're going to bring it to a compressor and bring the pressure back up to where CO2 is able to be kind of chilled and converted back into a liquid. So these things happen at high pressure. So you're going to capture that gas. You're going to bring it up to about 300 PSI. And then we're essentially going to chill it or change its state so it becomes a liquid again. And once it becomes a liquid again, we can put it right back into the process or right back into the storage tank. And that's about what those storage tanks operate. So we're kind of taking the CO2 that's now at atmosphere and we're changing its properties so that it can live again inside the storage tank. When we're dealing with sources outside of dry ice, even think of ethanol, where a lot of our CO2 comes from today, you do have some other impurities in there. Nitrogen, oxygen, anytime that CO2 touches the air, those things mix in. And in that point in time, we actually lose those impurities by that change of state or that change of phase of the CO2. So CO2 turns to liquid at a much higher temperature than nitrogen and oxygen. It takes like a lot of chilling to get a nitrogen or oxygen to turn to liquid. So what we do is when we turn the CO2 into liquid, the other impurities, they stay in their gaseous form and they disappear. And that's how we separate basically air from CO2. It's compression and then refrigeration.
Yeah, that leads into a question I think would be interesting is when you have companies that are selling CO2 for the beverage market or the medical market, is there additional purification that needs to be done for that? Or is that make it such that once you recaptured it, it's by that activity that's happening, all that's flashed off and then it's still now back to being a beverage grade or food grade?
Yeah, it's totally going to depend on the source of the CO2. So with dry ice, because everything's in kind of a contained environment, you're basically going to get right back to whatever the source of CO2 was that you purchased. So if you bought a beverage grade CO2, that off gas or that flash never touches the ambient atmosphere. It comes out of the chamber of the block press. And more or less, we can say it's going to be beverage grade. We'll put some filtration on the front end, some carbon filters. We will do some things, take some precautionary measures. But for simplicity, it's staying in the state you bought it in. When you're buying or when you're taking CO2 and converting it to a liquid from outside sources, yeah, additional filtration will be needed because we talk about nitrogen and oxygen being in there because that's what air is made up of. But there are plenty of other impurities, and beverage grade is 99.99, so 2 nines. I believe medical is 3 nines on the back end. And then, in addition to that, there's a whole list of things that cannot be in that CO2, even in the most trace amounts. And those are the things that we have to filter for or burn out. So it depends on the source of the CO2. But yeah, George, we'll do an analysis on the front end. We'll basically grab a sample and say, what is all made up of your CO2? And then we will kind of develop our solution to capture it around that makeup and around the specifications that are driven by the different industry, food, beverage, or medical.
So when we look at capturing, because capturing is pretty darn cool when you think of the different markets where things are at now. Ethanol, a lot of it, there's like 52 massive plants in the country doing ethanol. I think something like at one point, something like 40 of them were shuttered due to, cost and be able to produce and be economical and maybe even demand for the product. At that point in time, that caused a lot of, reduction of CO2 availability. But what are some of the other areas that you find? I mean, is it fertilizer plants, chlorine? Where would you say are the big ones that are CO2 sources?
Yeah, so the math generally breaks down. You can say 25%, 25%, 25%, 25%, but roughly about 30% of our CO2 merchant supply today in the U.S. comes from ethanol plants. About 25% comes from ammonia plants. 20-ish or so percent comes from the geological domes, specifically the Jackson Dome down in Mississippi. And then 25% is kind of some of those other things, a chemical plant, power generation, things of that nature. So yeah, when an ethanol plant, when natural gas prices are high, grain prices are high, or oil production is low, that we don't have as much demand on ethanol or production of ethanol, that impacts this market, our markets greatly. And so when we don't have to jump ahead to the questions, but when you talk about things like sequestration and 45Q under the Inflation Reduction Act and pipelines that are being developed, they're mostly being developed around the ethanol business model because that's where there's a lot of CO2 already, and there's also good geological structures underground to sequester some of that CO2. So as those do become impacted, then yeah, we need more alternative sources because things like ammonia, as we go into green ammonia and ethanol, those volumes are going to go offline.
Yep.
Someday.
And to touch on that, for all the folks listening, this is where there's going to be a pipeline going between all the different facilities that are producing the massive quantities of CO2
Correct.
to sequester it. And then depending on the rock formations, they can have put that in the ground to be stored for the millenniums and not be back out in the atmosphere. And then the CO2 we use, my understanding is a derivative of cost over and above whatever that would be to put it in the hole. If you want to pay for the higher price than that, that offsets future opportunities that they have for sequestering. So that sounds like that might cause even more of a shortage of CO2.
That is certainly the fear. I mean, currently the Summit pipeline is the most active one. There's a couple other ones kind of in the Southwest also active, but Summit pipeline is kind of the Pacific Northwest area. And they're you mentioned those 50 odd ethanol plants. There's at least 3. I think they've already signed up 39 ethanol plants that have their CO2 totally sequestered in that pipeline. At least 3, upwards of 5 of those are current suppliers to our merchant market today. So you're talking, thousands of tons per day that could go offline just on that one pipeline in the next 3 to 5 years it gets built out.
And I think something interesting on that point is, shortages are probably the likely outcome. But what's so funny is we hear about, and Jeff and I had this conversation yesterday with some students actually in university. All we hear about in the media is too much CO2, too much CO2. And there actually is plenty of CO2, but that transition to go from the easy capture sources, the ethanols that we're familiar with, to some of these new sources, if these ethanol plants and others were to put their CO2 into the pipeline, will take some time. So there will be a bridge gap period where we had traditional sources, they sequester, the market feels that pain, and we have to branch out into new sources of CO2 to supply the needs of the utilization market. And that's where the gap will happen. And that's where we'll see shortage, even though, yes, there is a surplus of CO2 in the world.
And then if we're going to be capturing it, as you said earlier, depending on the source it comes from, it might have other impurities that have to be cleaned through that. So if I was to ask each of you, like the coolest thing you think is going to happen with CO2 in the next 10 years, emerging wise, next 10 years, what would be, you guys are just day in, day out thinking about CO2, right? Every moment. CO2.
It's all we're so passionate about it. We don't even sleep because we're just thinking about CO2.
CO2, right? Bubbly drinks, whatever it might be. You're thinking about CO2.
We only drink carbonated drinks. We don't just drink water.
I think we have the same answer, but I'll give my answer. We get called out often because we're anti-direct air capture.
Hold on, wait, Jeff. Let me give my answer.
Hey, what's your answer?
No, I'm kidding. Please.
Yeah, it's the same one. Yeah, but we're not. I'm not a big advocate of sequestration because I don't think it solves the problem. So yes, will we see sequestration in the U.S. and across the world? Most likely, and that will take these sources offline. Is direct air capture the way to go, or are you better served getting it at the point capture? If you have a power generation plant, you're producing a tremendous amount of CO2. Capture it there while it's 10% volume and density in the air instead of 0.04 capturing it at the air. So yeah, some days I wonder which is the best way to go if we're going to sequester. But to answer your question, the thing that gets me most excited is the idea of going direct air capture into direct use. So that merchant market that we're talking about, that whole idea that there's CO2 everywhere, there is. It's just expensive to get to, which is why we use ethanol and ammonia sources because they're so clean and pure when we get it, as Luke was alluding to. So the real technology gains are going to be on small scale self-service models to where you're capturing the CO2 and you're serving your own needs on site that could disrupt the entire independent gas distributor, major gas distributor market for CO2. Our current supplies and distribution models for CO2 could dramatically change. And the question is, who's going to change with it and get out in front of it? And I think the technology is slowly getting there. The volumes of these small scale units are at most about a ton per day, and they cost, $600, $700, $1,000 a ton. That's not viable yet. But the technology scale is growing and getting there much faster. There's some really great companies out there doing some really neat things. And the question is, how can we integrate that into our business here in the independent gas distributor markets to serve existing markets, just do it a different way? I think that's the most exciting thing that happens over the next 5 to 10 years in our industry.
Okay.
I definitely agree. I will just take it one step further. I think the byproduct of that is the utilization of CO2 to create different feedstocks. Maybe some of these feedstocks that are produced through drilling and oil and gas right now today, but actually repurposing CO2 to be able to create products like the T-shirt that I am wearing right now through the fundamental changing of CO2, the building blocks of CO2. And to Jeff's point, there's some really interesting companies that are capturing CO2 right now. And there are some really interesting companies that are developing products around the changing of that CO2, into polycarbonates and ethanol and ethylenes. And so I think in 10 years, being able to say, my clothes were made from CO2. Jeff and I work with an interesting company. They were making diamonds out of CO2 and changing, CO2 to methanol and then creating a diamond from that and saying, this diamond came from the air captured CO2. So the transformation of products around CO2 and basically creating a whole new utilization market around CO2, one that we have not seen before, we are not familiar with, is what I'm most excited about. And I think is the most interesting. And part of that is because you're now creating consumer demand for the utilization of CO2. You're less reliant on the government incentivizing people to capture and sequester CO2. You're creating true built-in demand for products around the use of CO2 and the changing of its nature.
Yeah, that's great. I also think it'd be interesting when you look at things further out and think, how would you do the more significant farming and utilizing CO2 and production and quality and output, especially in parts of the world where that's a real issue, being able to get enough food. I know it's not
Absolutely.
realistic right now from a broad sense for us in agriculture, but it's interesting ideas of how could it be and what could be. There's a lot of really neat things around CO2 and what it really does. You hear a lot of bad things in the news,
That's a
but
great application for that direct air capture. Is direct air capture, purify it, clean it back up, and then use it in greenhouses. We're already using CO2 in greenhouses, but quite often what they do is they just burn natural gas or burn methane. You get a
yeah,
60%, 40%, methane and CO2. So they're just kind of burning fossil fuels to generate CO2 to make the plant grow faster.
yeah, it's
What if
very
we just
true.
capture the CO2 we already have and use
Oh, that's great.
Yeah, right. I know there's that piece of equipment out there. If you have a lot of mosquitoes, and it will do a similar thing. You use a propane tank, and it
it?
makes it such that the output and all mosquitoes want to go over next to that thing and keep away from you. But again, it's just exciting. It's really an exciting market that doesn't have necessarily everybody understanding just how exciting it is and what it touches.
We're
And
so early, George. We're so early to this market and the things that it could be.
Well, there's such a negative connotation around CO2, and that's why we say find new and constructive uses. Everything that we touch, and like you said, the shirts and the clothes and this pen, whatever, it's all made from hydrocarbons. It's all made from hydrogen and CO2 at some level. If we ever want to get off of fossil fuels, in the next 50, 100 years, then find renewable sources of those same equivalents. And that's what a lot of these companies and technologies are doing. They're capturing existing CO2 and reusing it, making ethanol out of captured byproducts of these things. And then one day we'll minimize the need to pump more oil out of the ground because we're just regenerating what we already have. But we don't have to change everything about how we live and what we do and we don't have to keep paying. That's why I'm against sequestration long term, because it never goes away. Right? Like we're always going to be paying a tax to put things in the ground and store it there that nobody benefits from directly, financially. So, with all the federal government subsidies. So let's find more innovative uses to make all these products from the regenerated CO2 and hydrocarbons that we already have.
well, and I'm so glad we had you guys on the podcast today because, the high pressure podcast, it's exactly what we want to do is look at things where the opportunities could be there, do things a little differently than how they are doing it. And then purely education of what a particular market is or a particular product and how it can be used. And you guys did a great job today helping open up all those ideas and thoughts out there. So I really appreciate that. Marie, do you have anything you'd like to add to the high pressure podcast today?
First of all, I want to let everyone know that Jeff and Luke also run their own podcast called Catching Carbon. It's fantastic. And you can learn a lot more about CO2 by giving that a listen or a watch. But I don't know. I have questions around, like government subsidies and the administration just changed. Do you predict that that's going to be changing anytime soon? Or do you think it's going to stay the way it is with the investments already made?
So, I think there's a lot of talk around the Inflation Reduction Act and really government spending in general. There's certainly from Trump specifically, JD Vance very specifically, aren't huge advocates of carbon capture sequestration, the CCUS portion of it. So the answer to your question is I don't think anybody knows. But it would take more than just saying we're not going to do this anymore. So yeah, there's already uncertainty around it. That's the biggest fear to me. It's the uncertainty of what's going to happen and where we're going to go. That's going to hinder investments into some of these technologies because a lot of these new technologies, like the direct air capture and some of these other technologies for creating these hydrocarbons, they need some of these subsidies. I'm an advocate of subsidies as they provide a runway to
Mhm.
get to profitability over that 8, 10, 12 years. They need some of those. But ultimately these businesses need to stand on their own. But when there's uncertainty, then nobody can do anything. We're at a standstill, which is a little bit where we are with the Inflation Reduction Act today and 45Q for credits for utilization of CO2. So nobody's investing. So yeah, the answer to your question, I don't think it's going to have a dramatic impact on it. But what we need to do is quickly get to understanding and clarity. This is where we're going. This is what we support. This is what we don't support, so we can move forward.
Absolutely.
No, I'm just going to ditto Jeff on that. for sure. And it is funny
Well,
because
wait, Jeff. Just so you know, Luke, on the high pressure podcast, there's no ditto. You can't do any dittos.
you have to have an original thought. I think I'm going to sign off then because
Yeah,
there's no place for me here. I will.
Commercial fun.
No, the only thing I will add is he's spot on. But we actually, if you were to look at the Catching Carbon podcast, when the IRA came out, we had a representation. We talked through it from a law firm that was focused on kind of tracking the utilization credit and understanding how people were going to get paid for using their CO2. A great example, does dry ice capture count as utilization for CO2? You're kind of recapturing and reusing and recapturing.
Mm-hmm.
Maybe not, but we don't know. Well, fast forward 2 years, we have the same group, the same attorney group on the podcast again to say, where's the clarity over the last 2 years? And it basically became a repeat episode. We're still not sure. We're still not sure. So Jeff is right. Even though people are worried about the change in administration, it's not like a lot of progress was made. It's not like the coin purse was opened up on these credits over the last 3 years, anyways. And I'm hopeful that we do get in front of Washington. There's a group through CGA that's out there lobbying a lot of the users of CO2. Hopefully, we come to a place where this new administration understands that we can accomplish climate goals while doing something net positive for consumers, for Americanism, manufacturing, and using the CO2. So it will be interesting to see.
One of the reasons that you think that a lot of this would sustain, like you take the Summit pipeline, it's not just about the CO2. And it's not just about the U.S. It's a global issue. So you have it's called your CI score, your carbon intensity score. So when you're producing ethanol, the value of that ethanol is based on your total carbon input, that whole life cycle analysis. So if you're producing ethanol but not capturing your CO2, then the value of your ethanol is lower than somebody in Brazil making ethanol sugarcane that is capturing their CO2. So they have no choice. They want to compete on the global market for these things. And states like California mandate certain, a blended average of your CI score of the products that they buy. So they can't buy your ethanol or other type of products, ammonia, things like that. So because of those reasons, these pipelines and things like that have to go forward. Now, are they going to be federally funded or are we going to be privately funded because it's a different marketplace for that? That's open-ended, but they have to do it regardless. So I don't think there's going to be a dramatic shift.
Interesting. And to end, I guess, what advice do you have, and either of you have, for a company that wants to expand their involvement in CO2 recovery and reuse?
I think this right here, listening to episodes, podcasts like this, trying to think outside of the box and getting creative and understanding that, the CO2 landscape is going to shift. So doing things the old way probably doesn't work. And frankly, we don't need more of the same. Market is saturated enough. If you really wanted to take advantage of it, it's not going to come in and be the 11th player in the traditional CO2 market. It's going to be listening to new technologies and kind of the groups behind them and seeing a play for new markets and then being the first mover to those markets. Showing up to conferences. There are a lot of CO2 conferences throughout the year and hearing from different speakers and then letting something kind of sit in your mind and kind of turn that over and figure out where is the opportunity. But it's not trying to do the same. It's not trying to do things how they've been done. It's looking for opportunity, in the niches here around the transition of CO2 based on the things that we've talked about today.
Mm-hmm.
Yeah, well, I would just piggyback on that and say, look to be self-sufficient. We have all this CO2 around. You use CO2. What are the opportunities to be self-sufficient and not so reliant on all of these other sources that are variable? And so, and then that reduces your greenhouse impact, footprint on your own facility. Capture your own CO2 and let us, change our mindset within the industrial gas markets of how we service those type of accounts to be able to serve those needs. And again, capture your own CO2 on site and use it. There's a real market for that. And it can be small scale, it can be large scale. We do it with hydrogen, we do it with nitrogen, do it with oxygen in certain circumstances. We can also do it in CO2 that's not being done today.
Great. Hey, I got to really say seriously, Luke and Jeff, thanks so much for taking the time today. I really enjoyed it. I learned a lot of good things. I know we're going to hear some really great feedback from all the listeners. So thank you so much for being on the High Pressure Podcast. And You guys have a wonderful rest of your day, and I hope you have a beverage tonight that's got bubbles in it with a little bit of CO2, and we'll all celebrate a great podcast.
Consider it done. Hey, we're always a phone call or an email away, and that's for all the listeners too. We just love to educate. The goal of the platform of our podcast and coming on here is not to sell, but to educate and to let you know what we're seeing. So thank you guys for the platform today. It was a pleasure, and we look forward to coming on a year from now and seeing where kind of some of these predictions shook out.
Sounds great.
Awesome.
Okay. Thanks so much, guys.
Thank you guys so much.
Yep,
Have a great day.
Thanks for watching. Stay up to date with the latest news in the gas and welding industry by clicking on the subscribe button.
And check out one of our other videos to learn more. Find out more about Reliably Ratterman at rmiordered.com.